this video, we will be discussing about continuous subarrays. You are given a zero-index integer array nums. A subarray of nums is called continuous if the absolute difference between each pair of the indices within that subarray is less than equals to 2. Return the total number of continuous subarrays. So what they are saying is that in the input, we are given an integer array nums. We need to find out that how many continuous subarrays are there. Now, firstly, what is a subarray? So a subarray is nothing but a continuous set of elements from the array, right? So 5 4 is a subarray, 5 4 2 is a subarray, 4 is a subarray, but 4 4 this is not a subarray, right? The elements have to be continuous. Now, what do they mean by continuous subarrays? So they are saying that if I am considering this as a subarray, then in this, for each pair of elements, the absolute difference between them should be less than equals to 2, right? So if we see here, 5 and 4, their difference is 1, which is less than equals to 2. 5 and 2, it is 3. This is not less than equals to 2, right? So this is not a continuous subarray, right? So we need to find out that how many total number of continuous subarrays exist in this nums, and that count we need to return as our answer, right? So first we will consider this 5. This 5 in itself is a subarray because 5 minus 5 is 0, right? So this is one of the subarrays. Then we will consider this much. So 4 here in itself is a subarray. So basically all the single elements, they all of them are subarrays, continuous subarrays, right? So we can just count them here, right? Then in 5 and 4, these are valid continuous subarray, right? Because the difference is 1. So we will consider them, right? Then if we consider next 2 length subarray, so this is 2 and 4, right? So this is also valid, right? The difference is 2. So one is 2 comma 4. Then next is this, right? This is also valid. So this will also be counted, right? Then if we see all the subarrays of length 3. So one is this one here. 5 and 4 are okay, 4 and 2 are okay, but 5 and 2 is not okay because the difference is 3. So we cannot count this. Then if we consider this one, so here 4 and 2, the difference is 2, okay. 2 and 4, again difference is 2, okay. 4 and 4, the difference is 0, that's fine, right? So this is also a valid subarray. So we will count this as well. So these are total 1, 2, 3, 4, 5, 6, 7, 8. So in this particular case, our answer is going to be 8, right? So now how are we going to solve this? So see, one of the basic brute force approaches that you find out all the subarrays, right? And then in all of those subarrays, you check for each of the pairs, right? You check for each of the pairs that are the difference between all of that pairs is less than equals to 2. Now that is a very huge time complexity approach, right? So let's not discuss about that. Let's think of something else. The constraints that are given to us is that the maximum length of nums can be 10 to the power 5. So we cannot go n square, right? We will have to think of something like n log n or n, right? So see, few things to notice here is that if I am considering a particular subarray, right? Now, if you see that the minimum element in this subarray is 2 and the maximum element in this subarray is 5, right? What is the difference between 5 and 2? That is 3, right? So, since the difference is 3, this is not a valid subarray, right? But if let's suppose in this subarray, instead of 2, we had a 3 over here. In that case, the maximum value in this subarray is 5 and the minimum value is 3, right? 5 minus 3 is 2 and 2 is less than equals to 2, right? So if the difference between the maximum and the minimum element in a particular subarray, if it is less than equals to 2, so can I say that all of the pairs in that subarray will be satisfying our condition? See, because if 3 was here and 5 and 3 were not violating the condition, so this 4 will also not violate the condition. Why? Because difference between these two is already less than equals to 2. So if we consider the elements in between the max and the minimum element, their difference with them will also be less than equals to 2. Right? So whenever we are considering a particular subarray, instead of checking all the pairs, what we can do is that we can compare the difference of maximum element and minimum element. If that difference is coming out to be less than equals to 2, then we can say that it is a continuous subarray, right? So since, as I said, we cannot find all the subarrays, right? We cannot go n square, right? So how should we approach now? So see, since we want to find a subarray, right? A subarray is continuous set of elements. So can you think of something known as sliding window? right? So this sliding window will tell us the valid subarray. We will expand and shrink it on the basis of some conditions, right? So when do we expand a sliding window? When our answer is satisfied or when our conditions is satisfied. And when are we going to shrink the window? When the condition is not satisfied, right? So what we can do is that we can maintain two pointers, right? Sliding window always has one left pointer which points to the starting of the window and a right pointer which points to the end of the sliding window, right? So we can maintain two pointers, left and right, L and R, right? Initially, both of them will be pointing to the first index only, right? And now, since we want to know that inside a subarray, which is the maximum element and which is the minimum element, right? And if in any case our condition gets violated, in that case, we need to shrink our window by moving left forward, right? So basically, at each step in a sliding window approach, we move right forward. At each step, when we are moving right forward, we will compare the maximum element and the minimum element, right? If their difference is less than equals to 2, then we'll just keep moving R forward. But if it becomes greater than 2, in that case, we will shrink our window by moving left forward, right? And since you would be moving left forward, then if your maximum or minimum value was that particular left pointer itself, then your min and max should also be updated, right? Because if I'm saying my max was 5 and I have moved this left forward, so now my max is no more 5. It is not there in my window. So my max should be updated to the maximum element which is in my current window, right? So what we can do is that we can take a map. Now, why do we want to take a map? How it will be helpful? So, when we take a normal map, so map are of two types, ordered map and an unordered map. In an ordered map, the values are stored in a sorted order on the basis of the keys, right? So, what we can do is that whatever are the elements in our current window, all of that elements we can keep inside our map. And since map will store them in sorted order, so what I can do is if my map is, let's suppose, NP, then I can take its begins first, right? So this will give me the smallest element that is currently present, right? And if I will do MP dot reverse begin and it's first, right? So this will give me the greatest element that is currently present in my window. So with these two, I will be able to identify that what is the minimum element and what is the maximum element in my current window, right? So if they are satisfying my condition, then I will count that subarray and I will move my R forward. And if they are not satisfying my condition, then in that case, I will move my left forward. So while I am moving my left forward in the map, I will also have to update that this 5 is no more present in my window, right? So let's quickly do a dry run and understand how are we going to utilize this map. So initially, my left and right both would be pointing to the index 0, which is element 5. So we will update the element 5 inside the map. So its frequency will be 1, right? And now, what is the minimum element and what is the maximum element? So both are 5 and their difference is 0, which is less than equals to 2. So the condition is satisfied and we should count this subarray in our answer. So this is one subarray. So answer would be 0 initially and now it would become 1. Now what will be the formula for counting the subarray? So see, this R will keep on moving towards the right one by one. Right? So whenever we find a valid subarray, what we can do is that we can identify that at a particular index R, how many subarrays are there that are ending at that particular index, right? We will see once this R moves a little forward, you will be able to get a clear understanding of how can we identify that how many subarrays exist. So now there was only one subarray, we counted it in our answer, right? And now we will move our R forward. So R will come here. This will be updated in the map. Corresponding to 4, the frequency will be 1. Now here the maximum element is 5, minimum element is 4, difference is 1, which is less than equals to 2. So this is one of the valid subarray, right? Now here, how many subarrays are there? One is 5, one is 4, and one is 5, 4. But this alone 5 we had already counted earlier, right? So what we will do is that we will only count those subarrays which are ending at that index R, right? So how many subarrays are there? One is 4 and another one is 5 and 4. Only 2, which is nothing but the length of this subarray, right? If we consider this subarray, then if we try to find out that how many subarrays are there which are ending at this index, right? Then how many it will be? 1, 2, 3, and 4. which is nothing but the length of this subarray, right? And how do we identify the length of our subarray with this R and L? So we identify it using R minus L plus 1. So with this formula, we will be able to identify that how many subarrays are there. So when my L and R both were at index 0, at that time it would be 0 minus 0 plus 1. So we got a 1 and we added it in our answer. Now my right is at 1 and left is at 0. So it will be 1 minus 0 plus 1, which is 2. So total 2 subarrays. One is this 4 and one is 5 comma 4. So 2 will be added in our answer and answer will become 3 now, right? Again, we will move our R forward. This will be updated in the map. So corresponding to 2, the frequency will become 1. Now, the maximum element is 5 and the minimum element is 2. Their difference is 3, which is not less than equals to 2. So now it means that we should shrink our window, right? Now, when you will be shrinking your window, you would be moving your left forward, right? So now when we are moving left forward, this 5 will no longer be present in my current window, right? So I will decrease its frequency from the map. So it will become 0. So now when this 5 its frequency has become 0, it will still be present in my map. And still, when I will try to access the maximum element from the map, it will come out to be 5, right? So, whenever the frequency of any particular element inside the map comes as 0, we will erase that particular key from our map, right? So here the frequency of 5 has become 0, so we will remove it from our map. We will erase it, right? And our left will come here now. Right now, the maximum element is 4, minimum is 2, difference is 2. The condition is not violated, right? So we will now calculate the number of subarrays. So R is at 2, L is at 1. So again, this is 2, right? So answer will become 5 now. Then R will move forward, R will come here. The frequency of 4 will change to 2. Maximum element is 4, minimum element is 2. Difference is 2, which is less than equals to 2. So we will count these also. So it will be 3 minus 1 plus 1, that is 3. So our answer will become 8 now, right? Then we will move our R forward. Then we have crossed nums. So then that means this is our answer. And we saw earlier that the number of continuous subarrays that we got in this particular case was 8. And this is what we have got, right? So this is one of the approach. Let's quickly look at the code of this approach. So first of all, we have created a map named frequency for storing the frequency of the elements that are present in our current subarray. Then we have created a left pointer and a right pointer, which are initially pointing to the index 0. Then we are taking the size of the nums vector and an answer variable for storing our answer. Then we are running a loop that while R is less than n, meaning we are going towards the end. R is going from index 0 till n. Then we are updating this particular element, the frequency of this particular element inside the map. Then we are checking that take the maximum element from the map or the key and take the minimum key from the map. If their difference comes out to be greater than 2, then that means we will have to shrink the window. So while we are shrinking the window, we will have to decrement its frequency by 1. And if that frequency becomes equals to 0, then erase it from the map, right? And at each point, increment left by 1. So once our condition is satisfied, we will come out of this loop and inside the answer, we will add the number of subarrays, right? And R will be incremented to 1 in each iteration, right? And at the end, we can simply return our answer, right? So now in this particular case, R is moving from 0 till n, right? So this while loop would be running n times. Now inside this, we are using a map. Now, in a map, in the worst case, how many elements would be present? So see, we are given that the difference between the maximum and the minimum element is less than equals to 2, right? And we are only storing the valid elements inside the map. So at max inside the map, only 3 elements can be stored, right? The ones having the difference as 0, the ones having the difference as 1, and the ones having the difference as 2, right? And the map will store one element only once, right? Because the frequency is being counted in the value of that particular key, right? So at max, the size of my map can only be 3, right? So inside the map, all of these operations take log k time, where k is the size of the map. And in this particular case, the size of the map is 3. 3 is a constant, right? So what I'm saying is the time complexity of this code is n log k, but k is 3. So log 3 is the constant. So we can say that the time complexity will be near about to order of n, right? And what will be the space complexity? So as I said that in the map at max 3 elements will be present, right? And 3 is a constant. So we can say that the space complexity is constant, right? Now there is one more approach of solving this problem. So let's look at that approach as well. So here, let's try to remove the dependency of this map, right? Map we were using to identify the minimum and maximum element in the current window. If we try to remove this map, then what is the approach that we can follow? So see, so let's consider this particular example. Now, in this, what I will do is that at each point, I will maintain the current maximum and the current minimum in my window. Basically, I will be taking two pointers, mini and maxi. This will tell me that what is the minimum element in my current window and what is the maximum element in my current window, right? And L and R will be initially at index 0 only, right? So whenever we will be moving our R forward, we will update minimum and maximum both. And with these, we can check whether the condition is being satisfied or not. And on the basis of that, we will expand and shrink our window, right? So let's see what are we going to do. So initially L and R both are at index 0, right? So mini and maxi both will be updated and they will become 3 now, right? Now we will find maximum element is 3, minimum element is 3, their difference is 0, which is less than equals to 2. So we should count this subarray. Answer is 0. Inside this, we will update the count, which will be 0 minus 0 plus 1, that is 1. So answer will become 1. Now our R will move forward, it will come here. Now mini will remain 3, but maxi will be updated to 5. Now 5 minus 3 is 2, which is less than equals to 2. So we will count this. It will be 1 minus 0 plus 1, that is 2. So now our answer will become 3, right? R will move forward, it will come at 4. Mini and maxi will remain as is, right? The difference is still less than equals to 2, right? So we will find out the length. It will be 2 minus 0 plus 1, which is 3, right? So our answer will become 7 now. Again, we will move our R forward. R will come here, right? Again, minimum and maximum will remain the same and difference is still less than equals to 2. We will calculate the number of subarrays. So it will be 3 minus 0 plus 1, that is 4. So it will become 11, right? Now we will move our R forward. Now our mini will be updated to 2 and 5 minus 2 will now become 3, which is not less than equals to 2. Now at this point, we should shrink our window and move our L forward, right? Now, till when are you going to move your left forward? So you will see that when L is here, the difference is coming out greater than 2. So you will move your L here, right? Still maximum is 5 only. So the difference is still greater. Then you will move your L here. Now you will see that inside this minimum is 2 and maximum is 4. So here the condition is satisfied. So this I can take, right? But you don't know. You don't know that when you came at this particular index, what are the elements present here? It might be possible that when you came at this 4, there is an element somewhere in between, which is 5, right? So that is not a valid window because 5 is present in between. So the maximum element is 5 and the minimum element is 2, right? So now how you will get to know whether there is one more 5 present here or not? I said we won't be using any map to store that how many occurrences of 5 are there or at what all indexes 5 is present. So now what to do? So one of the possible ways is that move this left towards the right till R, right? So if let us suppose my array is 3, 5, 4, 5, 5, 3, 2, like this. Your left is here. So what you will do? You will move your left forward and you will check this. This 5 is violating the condition, right? So this will be one of the index where you could keep your left, right? Then you will find out that, okay, this 5 is violating the condition. So I will check the next element. This is also violating the condition. So I'll check this element. So now this might be my left, right? So now you will check these two also and then you will see that, okay, all of these are satisfying the condition. So this is the index where I should keep my left, this 3, right? Here I should keep. So your L was here and your R is here and you traversed all the way from L to R to find out that what should be the new L, right? And that would increase our time complexity, right? So, since we want to skip all 5s here, right? We want that whichever is the last occurrence of 5, I will take the index next to it, right? And for finding out that, I had to traverse all the way from left to right. So, what we can do is that instead of moving my left from here towards the right, I will keep my L at R. If my R is here, I will keep my L here and I will move L in the backward direction, right? And in the backward direction, as soon as I get an index which is violating, I will stop and I will say this is my valid left. Here I will keep my left. So with this, we won't have to always move our left towards the right, all the way to all the elements, right? So what I am saying is that whenever my condition is being violated and I have to move my left forward, I will first point left to the index where R is present. So L will come here, right? And then I will check that whatever is the previous element, that is left minus 1, whatever is the previous element and whatever is present at the index R, what is their difference? If it is less than equals to 2, then that means they are valid. So now I should check the next previous element. Again, I will check this 4 and 2. If they are satisfying, then I'll check this. And I will keep on checking until I found a index where the condition is being violated, right? So what you will do is L has come here. So now when my L has come here, I have started a new window, right? Since now I have started a new window, my mini and maximum will change now. So right now both L and R are at element 2, right? So both mini and maximum will become 2, right? Because this is my current window. Now I will check the difference of the previous number and the number which is present at index R. So basically I will check that the absolute of nums of R minus nums of left minus 1. So this should be less than equals to 2, right? So in this case you will see R is at 2, right? So 2 minus L minus 1. So which is this particular element. So this is 3. So it will be minus 1. Its absolute will be 1. 1 is less than equals to 2. So this is valid, right? So we will move our left here now. Now we will compare this 4 and 2. So their difference is 2, which is less than equals to 2. So we will move our left, right? Now we will compare 5 and 2. So now their difference is 3 and now the condition is violated. Then that means this is my valid window now. I cannot move this L towards the left anymore, right? And while we were moving this L towards the left, we would also update our minimum and maximum. So when we were at this index 2, both L and R were here. Then we moved left here, right? So now the maximum would become 3. And then we moved our left to 4, so maximum would have become 4. So this is what our minimum and maximum will be, which are the minimum and maximum elements in our current window. So now that we have got a valid window, we will have to count its subarrays, right? So that will be 4 minus 2 plus 1, which will be 2 plus 1, that is 3, right? So in our answer, we will add 3. It will become 14 now. Same process we will follow. That again, R will move here now. And again, maxi will remain same. We will again count. And then R will move here. Then we'll check. Then it has crossed the limits. So we will stop. Then whatever will be in our answer, that is going to be the count of the subarrays and we can return it, right? So this is the approach that we are going to follow. So let's look at the code. So first of all, we have taken our left and right pointer. Then we have taken a mini and a maxi variable and our answer is 0 initially. Then mini and maxi initially we can keep them equals to the first element inside the nums vector, right? Then we are looping for R from 0 till the end and we are updating our minimum and maximum. So mini is equals to minimum of mini comma nums of R and maxi is equals to maximum of maxi comma nums of R. Now we are checking that what is the difference of maxi and mini. So if maxi minus mini is greater than 2, then that means the condition is violated. So we will have to shrink our window now. So first we will shift L towards R and then we will start moving our L towards the left, right? And since we have moved L to R, minimum and maximum will be updated to nums of R, right? Now we will check that while R L is greater than 0 and the absolute of nums of R minus nums of L minus 1 is less than equals to 2. We will keep on expanding our window, right? So we will do left minus minus and we will update our minimum and maximum, right? And once this condition becomes false, we will come out of the loop and we have got a valid subarray. We will count its length in the answer and at the end we can return this answer, right? So let's run this code. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.